Welcome. Logging is done to keep the record of event occurs while running the application. So when application runs into trouble, you can view the log in order to identify the problem. And when debugging the application also, if you have set up the logs properly, you can view the variable value at each iteration in order to identify the problem. First, we will see the levels of log and at each level what information you should log. So here are the levels of logs from increasing level. So lowest level is debug and highest level is critical. So at the debug level, the very detailed information how your function or program works is logged. And when resolving the issue, the programmer should be able to understand internal working of function by viewing the logs. So whatever the functionality and the flow you are writing as a code, that must be logged. For example, if you are modifying the value in the loop, so at each iteration what variable values you are modifying, you need to log at the level of debug. Next level is info. So it is a confirmation log which indicates that program is behaving as expected. So method starting with the param and ended successfully with this parameter. You are returning these values and you are getting these parameters, and all the internal function you are invoked are getting executed properly. You logged at the info level. Warning. It indicates the unexpected event occur, such as high workload, which can cause a problem in response time, but your program will behave as expected. So in that situation, you log the warning. For example, you can also log the warning when invalid login is attempted. And next level is error. So due to certain problem, some functionality is not performing as expected. In that case, you can log an error, which we saw in the exception section. And highest level is critical. Due to serious problem, program cannot be run. So in that case, critical level of log is logged. Now for each log level, there is a log method in order to log the record or the message. So these are the method, and all the methods have same parameters. So first parameter is message. Message is the string which we want to log, and it can take variable amounts of positional and keyword argument. So we will see what are the keywords argument which you can give. And while logging, by default logging level is set to warning. So as we have explained earlier, these are the levels of log in their increasing order. So they have hierarchy. So by default it is set to the level of warning. So logging will only process the logs which is at the level of warning or the higher. So the log with warning, error or critical method will be processed, and if you have log with info or the debug level, they will be ignored. This is the example. First we will import the logging module and we will log the simple message at each level. So by default we know it is set to the level warning. So if we execute debug, which is at the lower level than warning, this function will not be processed. As we can see the output, it is by default redirecting your logging message to std error. Here we can see warning and error message, but there is no debug message. When the debug function is executed, it checks the level against the current level set. So it is lower, then it is not logged. Now we will see what are the arguments. It takes positional and keyword argument in variable amount. The positional argument is given for the message string. It can be a formatted string, and the placeholder which you place inside the string message can be replaced with the positional argument. And keyword argument, these are the only possible keyword argument that can be passed to this method of logging level. So first one is a execinfo. So by default it takes the exception information which we saw for the sys.execinfo returns. So it returns the tuple object containing the exception information. Same information is taken by this parameter. Next one is a stack info. By default it is set to the false and it takes the boolean value. If it is given true, it adds the stack information to logging message. Now how it is different from the execinfo? So we saw the traceback. It prints the stack information where the exception has occurred. So same way, if we want to print the stack information for any function which is not producing any exception, we can use stack information. So for any normal functionality which is not producing exception, it will print the stack information where it is originating from which file, at which particular line it is coming from. All the information can be logged using stack info. Next is stack level. By default it is set to 1. If it is given value greater than 1, it skips the frames while computing the line number. So if you are using framework or designing a framework and you want to skip some frame while logging, you can use the stack level. And last one is extra. It takes the dictionary object as an argument which is given as a key value pair. It is used for formatting the log record. Now what is log record we will see in a minute. So first we will see the positional argument. So here we have given the formatted string and this is the positional argument. So it will replace this formatted string with the given value. As we can see, placeholder is replaced with the given positional argument. Now we will set the log level. So it is by default warning. Now if you want to change it in command line, we can write like this --log and the level of logging which we want to set. And if we want to set it programmatically, we can use basicconfig function which take parameters, and one of the parameter takes the level of logging. So you can also set at the basicconfig. So let's see the argument or the parameters of the basicconfig function. So it sets the basic configuration for the logging, and it must be configured before any logging function such as debug or info is executed. And its signature is it takes the variable amounts of keyword argument. So what are the arguments you can pass is explained in this table. So first is a file name. It is a name plus path of the file where you need to log the records. And second one is a file mode. So by default we have seen the logging is redirecting your log record to the standard error. But with the basic config, if you set the file name, your logs will be redirected to the file instead of the standard error. Next is a file mode. By default it is set to the append, but you can assign any other value using this parameter. Next is a format. It is a format of a log record. So you can customize the format of log using this parameter. We will see in detail what are the parameters you can use as a format the record. So these are the some of the parameters you can set, such as this. If you write this, you can print the current local time in the record automatically. Second is a name, the name of logger to be log. Next is a log level and the message string which is passed to the log method. Next parameter is dateFMT. It is a date format. If you are logging the date, you can assign the format of a date. It uses the same format as we saw for the strf time in a datetime module. Next is the level. Now here we can set the level of log. So if we set log at debug and if we see the level, you are setting the log level at the lowest. So it will log the message from debug and all the higher level. So if you set the log level at the debug, it will log all the message which is logged by the application. And according to the level, you can set as per the application requirement. Next parameter is style, which specify the format of the message. So earlier we saw with the positional argument, we formatted the string using %, which is a by default, but you can customize the string formatting using the curly braces or dollar. Curly braces we saw with the format method, a dollar we saw with the string templating. It is same as that. And this is the %, which is a default value for the style, but you can modify and set it to the other value also. Next is a stream. So it is a stream handler for the log destination, and file name must be blank if this is specified. So you can either specify the stream or the file name. File name, you are redirecting your log to the file, and with the stream handler you are redirecting your log to the stream, which is either standard error or the standard output. So you can only provide one of these two arguments. Next is handlers. It's a iterable of handlers to be added to the root logger. Now we will see in details what is handlers and what is the root logger in the logging hierarchy. And next one is force. So if it is set to true, removes all existing handlers attached to the root logger before carrying out the configuration as specified by the other arguments. Now first we will see what are the format customization which we can do in order to print the log message. So this is the table of symbols or the attribute name which we can use in order to format the record. It contains the pre-configured information that can automatically be included when creating the log message. So for example, if you write this in your log format, it will automatically include the current local time in each of your log message. So for the same millisecond, it will include millisecond part of time when the log was created. Next is relative created. It is a millisecond of time when the log is created relative to the when the logging module was loaded into the memory. Next is a log level. We know log levels, debug, info, warning. So whichever the method is used, that log level is printed. Log level number. It's a numeric logging level for the each logging method. So from starting from debug, it is having level number as a 10 and it increases by the 10. So for info 20, for warning 30, for error it is 40, and for critical it is 50. So if you want to print the numeric log level, you can print it using level N. Name of the logger. So we will see how to name the logger in upcoming examples. This is the message string you are passing to the log function. Next is a path name. It is a full path of a source file where the logging was run. So from whichever Python file you are logging, this is the full path. It is printed using the path name. Module. It is a module name. This is a source file name where the logging was run. Next is a function name. It's a name of function in which you are executing the logging method. So you can also log the function name just by appending this value. So you don't need to explicitly write the function name when you are executing the log method inside a function. Next is a line number. Line number of a source code from the file in which you are executing the log function. Next is a process ID if available, process name if it is set, thread ID if it is available, and thread name is a name of thread. So now we will see each logging level has its numeric value here. So starting from 10 from debug, it is increasing by 10 until critical as a 50. And this is a special value for logging level not set. If any of the logging level is not set, you can use this special value which is having numeric value as a 0. And if we check it inside the logging module, these are just a constant variable which is having a numeric value. So if we execute it, we can see it is printing the numeric value which is held by this constant. So if you are passing any of this constant to any method, this numeric value is passed to set the logging level. So while setting the logging level, you must use one of these default variables. Now we will customize our logging using basicconfig function. We have seen what are the parameters we can set and how we can customize the format of log record. So this is the first example in which we will only set the logging level to info in order to log the info message. So we will provide level argument as a logging.info constant, and if we execute it, as we can see, it is printing the info level log. So by default it is set to the warning. So if we don't configure any of this thing and if we execute it, it will not produce any log record. So by setting it at info, we are able to log the level at the info. Next example is logging to the file. If we provide the file name and file path, your log message will be redirected to the file instead of printing to the stream. Here we have specified the file mode and logging level. So logging level is set to info. So info and all the levels above the info will be logged. So if we execute it, it will not show any output on the screen, But if we look at the folder content here, as you can see, a new file is generated, and in the same directory where this Python file is located, because we haven't provided the full path here, we have just provided the file name, so it will create a new file if it is not existing in the same directory of this Python file from where we are running. So if you open this log file, as you can see, it contains the log message. These are the log message. So here we have log message with the variable values. Same is logged inside the file. Now we will customize the log format. So using the parameters or the attribute names we saw in the format table, we have used those attributes and created the format. And here we have also specified the date time format, because here we are including date time information inside the log message. Afterwards, we are printing the log level name, module name, and the message. And we are logging at the level of info. So if we execute it, so we haven't set the StreamHandler, and we are only redirecting the output to the file. So if we execute it, new file will be created if it is not existing, and if we check it, our log message will contain the information specified in the format. So here we can see it is first printing the date and time. So date and time format is given this in same format, it is log. After that there is log level, module name, and the log message. So for each log function in this format, your log message will be logged. Next example is logging with threads. So here we are creating multiple threads, and with threads we are logging at the level of info. So using format attributes, we can print the thread names. We are redirecting the output to the file. So if we execute it, a new file will be created which will contain the log information of threads, because we are using multiple threads. So as we can see, the thread name is included in the log record. Now next is logging with extra parameter. So earlier we saw logging method contains parameter, last parameter of keyword argument is a extra, which takes the dictionary object which contains key value pair to log the custom attributes. So here we can see we have a dictionary which contains the application specific information which is passed as a extra keyword argument. So the same key value can be accessed inside the log format. So same key here we have used inside the format, so we can log the information which is generated at the runtime. So if we run it, and if we see the information here, we can see this is the log level numeric, and the name of logger, and afterwards, as we can see, this is the machine ID formatted from the given dictionary value. So you can use this extra parameter in order to pass additional information to the logging format. Now one thing here to consider is, while logging with this extra parameter, if you are including the keys of extra parameter inside your log format, you must always pass the dictionary object which contains this key. Otherwise it will raise error. So each time you need to pass, even if you don't have any information, you need to pass as an empty value, but your dictionary object must contain that key which is used here. We can resolve this problem to pass extra dictionary at each logging method by using LoggerAdapter class. We will see with the example. While using this extra, you need to keep that in mind. Now we will see what are the basic components of logging. So there are 4 basic components. First one is loggers, which provides an interface to the application for logging. Second one is a handlers. Handler sends your log record to a particular destination. So for example, we saw FileHandler and the StreamHandler in a basic config. So file parameter was automatically configured a FileHandler in order to redirect your logs to the file. And if you provide a stream argument, it will redirect output of log to the stream. So those are the handlers which handles your log message as per the configure of a handlers. Next is a filters. So filter decides whether to process the given record or ignore it. So you can customize depending on the message of the log or the content of the log. You can either log it or ignore the log message. Next is a formatter. So using formatter, you can customize your log record. So in basic config, we saw a format. So format attribute, we were providing argument to the formatter. So according to the format given to the formatter, your log message will contain information configured in the format. So this is the object composition of this 4 basic building block of object look like. So logger object can contain handlers and filters object, and each handler object contain filter and formatter object. So this is how the object composition look like. If you are creating handler object, for example, you can add filter to it. So while handling the log record, you can write logic in order to ignore certain log messages which are not important for the application. And you can also attach the formatter object in order to handle the log record in a certain format. So at the highest hierarchy level is a logger, which contains the handler and the filter object. So we will see with the example how you can configure the logger, handler, filter and formatter, and what are the attributes and their methods. So whenever you are logging, the log event information passed to the components in the form of LogRecord object. When you are logging, all the information is captured inside a single object of class LogRecord, and that object is passed to and from logging components depending on the configuration. We will see first some of the logging module functions. So first function is getLogger, which returns the logger with the given name. It takes only one argument, which is optional. So if it is not given, it returns the root logger. So earlier we saw example in which it was printing the name of the logger as a root. So root logger is a root of the logging hierarchy. So earlier we saw the module and import. So in that we saw modules and packages are arranged in the hierarchy of a folder, as we can see here. So file and folders are arranged in the hierarchy inside the Python program. So in the same way, your logger object can also be arranged using this getLogger method. So based on name, the level or the hierarchy you can define. For example, if you give the name of getLogger as a package a1.package b1.module a, so here we can see inside package a1, you can go inside that package b1, and inside that package b1 it is module 1. So this way, here it is not following the same way, but you can traverse in that way. So first folder contains package A1, inside that another folder package B1, and inside that your particular module is existing. So same hierarchy of your Python file you can configure using getLogger. And depending on the separator here, hierarchy defined in the name, your logging message will flow through. So we will see with the example how it goes through this hierarchy. And this is a singleton factory function, getLogger. So if you are executing getLogger for the same name multiple times, it will return the same logger object for the same name. And you don't explicitly create a logger object using logger constructor. You must always use getLogger method in order to create the logger object. Now we will see the LogRecord. So we explained that LogRecord object captures the logging information which is to be logged. The LogRecord object is created when executing any logging function such as info debug. All the logging information is captured inside the LogRecord object. We will study the LogRecord object's attribute in order to understand what are the information captured by it. And when we are customizing the logging functionality, we can use those attributes in order to get custom use case scenario. So these are the parameters used to create LogRecord object. This constructor is invoked internally when you execute the logging function. So name is the name of logger used for logging the message. So earlier we saw the getLogger function in which we are providing the name in a hierarchy manner. So the same name is captured in a name attribute. Level level of logging event, path name, the full path where the logging is called, line number of the source code, message string which is passed by the logging function, argument parameter of the logging function, exec info same as the logging parameter, this is the keyword argument of it. Scene info is a text string representing the stack information. S-info is a stack information from the base of stack in the current thread up to the logical call. And it has method getMessage which returns the message for this LogRecord instance after merging any of the user supplied argument with the message. So getMessage will construct the log message out of this information. This is the stack information. So we saw stack info argument as a true. We were passing into the log methods. So same will be captured inside this if it is provided as a true. And the primary information passed to the log records are the message and the argument in the form of this. As we saw that this is the default format. Next function is getLogRecordFactory, which returns the callable which is used to create the log record. Now this is the callable. It is called to create a log record when logging the event. And setLogRecordFactory which sets the given callable or a function provided as an argument as a log record callable which will get called when creating the log record. This is the signature of the callable which needs to be there if it is provided as a setLogRecordFactory. Now if you want to customize the log record, we can use these two functions in order to provide the customized callable which will invoke log record or construct the log record as per the application requirement. It has the same set of arguments as we saw for the constructor of a log record. So name of logger, level, full path name, line number, message, argument, exec info. This is new function. The name of the function or the method is being invoked, and sinfo is a stack trace info. So using these two methods, now we will create a log record. Custom value we will inject into the log record when it is getting generated. So here we are creating a customized function for LogRecordFactory, and whatever customization which we will make here will be applied to each log record object. Now customizing with this, we can inject new information. So as we can see here, we have added a new attribute to the log record being generated. Here we are attaching a pod information. So the same information attribute will be available to the format. So same attribute is accessed here. So earlier we were passing a new attribute using extra parameter with the dictionary object. So in that method, we need to explicitly pass that extra parameter even if we don't want to log for that particular log record. Because the key is used here, we needed to pass every time. But using log factory, here we are injecting at the level of log record. So after executing the log method, whenever the log record object is created, this information will be automatically injected into it. So we don't need to write any logic while we are logging any message. So what we are doing is, first of all, we are retrieving the older by default log factory, and inside the new we are invoking that log factory with the given arguments, and we are attaching our new information and returning the same record which is generated by the log record factory. And here we are setting the new record factory. So if we execute it, as we can see, the pod information is attached to the log record when executing a logging method, and here we are not providing any information. It is injected when capturing the event information while logging. So whenever the log record is constructed, it is injected. So here you don't need to manually insert here and pass the parameter in order to log the custom attributes. And same way we can wrap around multiple log factory. So here we have wrapped one log factory. You can also wrap new log factory on this in order to inject. And there is no restriction to create on chain, but there is one thing you should consider. The attribute name must be unique, which is you are injecting. So for each level, the attribute which is injected must be unique. Next method is disable. It overrides the log level for all the loggers in the application. By default it takes one variable as a critical, so if it is set to the critical it will disable all the logs. So it is used for temporarily changing the log level, and at the later stage you can also restore it. It disables all the log message of the given level and all the level which are having numeric value less than. So we know the critical is having the log level as the highest, equal to 50. So all the log levels below it are blocked. So same way, for example, if it is set to info, it will disable the logs of info, and the level less than it is a debug, which is having value 10. Info is having value 20. So it will block the info and the debug logs. When you have multiple logs in your application and for the performance reason or the debugging reason you want to limit the log level, then you can use this method. Next is a getLevelName. It returns the numeric value for the given log level, and if you give log level it will return the numeric value. So if we pass the getLogRevelName inside the level name, it will return numeric value, and if we pass the numeric value it will return the level. So let's execute, and so as we can see info level is 20 and at 40 there is a log level error. Next method is shutdown. Informs the logging system to perform orderly shutdown by flushing and closing all the handlers, and it is called automatically when application exists. So you don't need to manually call this method, it is being executed automatically. And when logging module is imported, this function is automatically registered as an exit handler, so don't need to call it explicitly. Next function is getLoggerClass. Returns the standard logger class or the last logger class passed using setLoggerClass, and it is called within the new class definition of when you want to override the default behavior. So you can create custom logger class using getLoggerClass. Here we are creating subclass of a logger class, which is a current logger class, and here we can modify it. setLoggerClass. So after modifying class, you can set your customized logger class using setLoggerClass, and user defined logger class must define init method with a name argument, and init method calls the logger.init. So here we haven't specified the body, but it must have init method which calls the logger.init, and it must have the name argument, and this function is typically called before any loggers are instantiated by the application. And in the module of application, only use getLogger to fetch the logger instance. As we have explained earlier, you don't need to explicitly call the constructor of logger class, just need to use singleton factory getLogger to get the logging instance. You need to give the name as per the hierarchy. It will return the object based on given name. Next is a makeLogRecord. Takes attribute dictionary as a parameter, returns the new log record constructed from the attribute dictionary. So if you have a log record which is pickled or it is sent over the socket, it must be in a dictionary or a Python object, and if from it you want to construct the log record, you can use this method. Now we will see the logger class and its attribute, so we can understand what are the attributes and how we can customize it if we want to customize it using creating the subclass of it. First we will understand the logging hierarchy. So earlier we saw getLogger method which takes one argument as a name, and name is specified in a hierarchy. So how the hierarchy works we will see with the example. Same as module and packages are arranged in the hierarchy, logging can also be arranged in the hierarchy. And logging is performed using logger object, and each logger object has its own name which identifies it in the hierarchy. So based on defined name, it is arranged in the hierarchy, and logger object must be instantiated using getLogger singleton factory, and multiple calls of getLogger returns the same logger object, and root of the logging hierarchy is called as a root logger, and logger also prints the name as a root. So if you don't give any name to the getLogger method, it will return the root logger. And if you are configuring basic config, and most of the configuration are performed on the root level, so whatever the configuration you perform on a logger object at certain level, it will be configured at that level. It propagates from the lower level to the upper level. So log record will be propagating through the level until it reaches to the root. And getLoggerName is used to create logging hierarchy, same as module and package hierarchy, and root logger always has set the logging level warning by default. So we know that at the highest level the root logger sits and it has the warning level of a logging set by default, and any other logger will have by default set as a not set level we saw earlier for that constant. So it is set as a not set and it is having numeric value 0. So it has two attribute. First is a level which returns the level which is configured for that logger object. So first of all we will fetch the logger using getLogger method and we will see the attribute. So here we can see a root logger is by default configured as a 30, which means it is a warning. And if you see any non-root logger, this is for current module which is main, it is considered as a not set. It is set as a not set. Next attribute is propagate. So by default it is set to true, which passes the message to ancestor of a logger handler in the logging hierarchy. So suppose we have set the logging hierarchy a.b.c and above all there is a root logger. If the logging message is generated at hierarchy level C, first it will handle by C, and if it is a propagate set to the true, by default for all logger propagate is set to the true, and when the log record is processed at hierarchy level C, it will pass to the B, and B will handle it, then A will handle it, and then it will pass to the root logger. So by this you can have a single configuration at the root level which will be applicable to the all of its children. So we only configure the logging at only root level, it will be applicable by all its children, even if we don't define any configuration at the any of this hierarchy, because by default propagate is set to the true, which will pass to its ancestor until it reaches the root, and at the root level it will find the configuration whatever the format, handler, anything we have set at the root logger level. And we can also customize at any of the hierarchy if we want a custom behavior for the same hierarchy at the particular level and it's all children, then we can also configure at the any of this level. So normally handlers are set at the higher level of hierarchy so that all of its children logger messages goes through the common handler. And if the handler is attached to the current logger and one or more parents logger also contains handler, with the default propagate set to the true, logging message will be handled multiple times depending on the handler's configuration. For example, we can configure a root logger as a file handler, and we can also attach one handler as a StreamHandler for package B. So both handlers are different. For the root as a file handler, it will redirect all the message to the file, and for B package and its subclass, it is configured as a StreamHandler. So it will also process message and display it to the any stream, output stream, or the standard error configured to it. It will also display those log message to the stream also. But the same message also will propagate to the root level. So this is the advantage of creating logging hierarchy. So you can configure multiple handlers in the hierarchy. If we have configured at level B, it will also print the log record to the stream, and at the same time all the log message will be recorded to the file also. And for the log messages of package A and root logger, they will only go to the default handler, which is a file handler if it is assigned, and it will only go to the file. So we can have a different configuration as per the application requirement. And if the propagate is set to the false, the logging message which is generated by that particular level is handled at that level only. It is not passed to the any of this ancestor. So suppose here we have set at the StreamHandler and propagate to the false, it will only display log message generated by this level, and all the children will be handled by the StreamHandler only. It will not propagate beyond this level. So we will check the by default value propagate for the root logger. So as we can see, by default it is set to the true. So let's see the example. So here we have configured the basic config at the root logger level, and as we can see inside the package A1 we have module A2, and it is getting the logger with the current logger name. So it will have this hierarchy of package a1.module_a2, for that hierarchy it will fetch the logger, and for package b1.module_b2 is having the same. So we are importing it and we are executing the hello module function, and we are logging a simple message from that function. So this module don't have any logging configuration there, but if we execute it, the root logger has the handler, so it is a file handler here, so it is redirecting the log to the file. So if we execute it, it will not display any output to the console because all the logs are redirected to the file. So as we can see here, first of all, hierarchy is created at the root level, and from package a1.module_a2, so this is the name of the logger, which is extracted from the name attribute, and this is from the package b1.module_b2. So this way the logging configuration or the log record is propagated to the root level, and root level has a file handler, and file handler has handled the messages. Now we will see the logging hierarchy with the multiple handlers. In module 2, we have added a StreamHandler which will redirect logging output to the standard error by default. So all of the logging message inside of this module will be by default handled by the StreamHandler, and by default we know logger set propagate to true, which will also propagate to the higher level or to the parent, and we know at the root level we have configured as a file handler. So the logging message for this module A2 will be handled by the two handlers. So let's execute it and see the output. So as we can see here, from module A2 from package A1, the log message from the method is printed on a standard error. And if we check the logs of a file defined in the basic config, as we can see, the same message which we saw here on the console is also logged into the file. So same message raised by the logger object or logging method is propagated to the root level, and it is also handled by the handler defined at that logging level. So in that hierarchy, whichever the handlers are there will be handling those log records until it reaches to the root level or until it finds a logger which has set propagate to the false. So we saw the attributes of a logger class. Now we will see the functions. First function is a getEffectiveLevel, returns the effective level of logging object. So we earlier saw by default the non-root logger have a logging level not set. In order to calculate the effective level, which will be inherited from the parent of it, and if that parent of the current logger module or logger object does not have set, it will go to the parent until it found the logging level. So by default we know the root logger has the logging level set to the warning, so it will propagate the query of the level until it find the logger object which is having level set, if it is not having logging level explicitly set. So for that calculation this method is used. Here we have two logger object, and we will check the effective level and the level at which configured by the logger object. So let's execute it first. So at the root level we know by default it's set to the warning, it is level 30, and for non-root level by default level is set to the not set. But if we execute getEffectiveLevel, it will query its parent in the hierarchy until it finds a logger object with the level set. So in this example, the non-root log level has parent root log level which has set the level as a warning, so it will calculate that effective level as a warning, but it does not have set the level explicitly to the logger object. Now each logger object have the same set of logging method as we saw for the logging module. So earlier we were using logging modules logging message, but if you are getting logger object, same logger object get by the getLogger function, it has same set of logging functions in order to log the messages. One additional function is exception, which has same signature as we saw for the logging message, which is same as a error level, but it adds the tag trace of the error. So with error, it will only format the message given. It will not print the stack trace by default. But with the exception, without giving any extra parameter, it will print the exception stack trace. So let's see with the example. So here we are using logging.exception when the exception is raised, and if we execute it, so it is a file handler, it will create a new file, and if we check that file, as we can see, it is printing error, which is the same message will be printed by the error method, but it also includes the stack trace. An error message does not include the stack trace by default. Here we are not providing any extra parameters. And for all of this method, there is one generalized method is log method, in which you specify the level explicitly at each time. So we know the log level and their numeric value. So we can provide explicitly in the log method in order to log the message at the particular level. So here we are providing warning, so it will create a warning level log. Next method is a set level, which sets the given log level to the logger object. Message with the given logging level or the higher logging level are processed. So if we setting warning and this all higher levels error and critical will be processed, including warning. So let's see with the example. Here set level is performed on the logger object and it is configured to the info. So all the logging level with the info and the higher level will be processed. So if we see the hierarchy, above the info level is warning, error and critical. So all this message will be processed and the debug will be ignored. So here we have a debug method. This function will be executed and whatever the message inside it will not be processed. So if we execute it, as we can see here, by default it will redirect it to the standard error. So we can see info and the error message and the debug message is ignored. Next method is add handler, remove handler, add filter and remove filter. So we saw object composition. Using this method we can add, remove handlers or the filter, and we will see them in detail. So when we will visit this handler and filter object, using this method those objects can be attached to the logger object. Next is isEnabledFor. Returns true if given level to this method is at that level, message will be processed or not. If the current log level is set as info, and if we pass isEnabledFor info, warning, error or critical, it will return true. But if we pass debug, it will return false. And it will internally execute getEffectiveLevel in order to extract the root level. So first it will check the disable. If the log level is disabled, it can return the false, and afterwards it will check with the getEffectiveLevel method. Next is a getChild, and inside it takes a suffix. It returns the logger which is a child of this logger with given suffix. So for example, if we write getLogger for package a dot getChild, which will be same as this getting a logger of this hierarchy. So if we have already a logger object and we want to get child of it, so instead of writing a whole hierarchy, we can use the getChild method, which will append the given suffix to the current hierarchy of a logger object. So if the current hierarchy of logger object is package A, so getChild with module A1 will result a logger object of this hierarchy. Next is handle. Handles the given record by passing it to all the handlers of this logger and all of its parent. It is used for processing record received from the socket or locally created. So you have record, which is LogRecord object, which is generated by your code, or you have received from the socket. You can handle it manually using handle. So earlier we saw the logging method. So they are handled automatically behind the scenes. So we don't normally see the LogRecord object and it getting passed to the logger object and it is handled. All of those processing are done in a background. Next is hashandlers. It returns true if the logger or any logger in the hierarchy has any handler configured it to it. So it will check for the handler. findCaller. It will find and return the caller's information in this tuple, which contains file name, line number, function name and stack information. So it is useful to find information about where it is getting called from. It takes two parameters, stack info and stack level. By default it is set to false, returns none as a stack information, but if it is given as a true, it returns the stack information of a caller, and if the stack level is given, stacked frames are ignored before determining which frames to return. So we will see it with the example. So here a file is module findCaller, and inside it we have configured the basic config in it, and it is calling logger findCaller. So we will see in the hierarchy first where it is. This module findCaller is located at the module file findCaller here outside the app logging directory, and inside the app logging there is a module logger findCaller. We can see logger findCaller inside the app logging, which is having this code, and it is having a function which is invoking a function from another module which is imported from the package A1 inside the app logging from module A4. So if you go to the module A4, it is having token generator function which is using findCaller function. So whenever this function is executed, it will find its caller, and it has set the stack info as a true, so it will also capture the stack trace information. By default it will only capture the caller, it will not skip the frame. So by default it is set to 1 frame. So this module is imported by the findCaller, which is inside the app logging, and it is calling that token generator function and logging the message, and this make call function is called by module findCaller inside the findCaller demo function, and findCaller demo is executed here, and module findCaller function is outside the app logging folder here. So it is creating the hierarchy like this. So we are traversing it. So inside the findCaller, it is calling make call, which is of inside the module logger findCaller, and it is invoking token generator of module A4. So this is the call hierarchy. Now if we have configured logger findCaller inside our function, and if we execute this function, it should capture the caller. It is calling from the here from module findCaller, and here we have configured the basic config as a FileHandler, so it will create a log file, and if we analyze it, so it is capturing the caller information in a tuple object, and that tuple object, if we see here inside the module, same tuple object we are logging inside. So what is the content of that tuple object? File name, line number, function name, and stack information. So if we see here, this is the file from which it is called. So we know module findCaller here, from it is called at which line number 11, and name of the function findCaller demo, and this is the stack trace from where it is called. So this way we can capture the information of a caller. When we are programming a function, we don't know from where it is going to be called, but if we want to capture those information, we can write a single functions. We can call the single function of logger.findCaller in order to capture the calling information. So this wraps up the logger object. Now we will move to the second component, which is handler. So handlers handles the log message and dispatch it to the specified target. You can add handler to a logger object using addHandler method. So first we will see the handler class. This is the constructor of handler class, which takes one optional argument level, which has by default value set to not set. So when creating an object or invoking init method, it does three things. First, it will set the given log level as an argument to it. Second, it will create an empty list and assign it to the list of filters. And third, it will create a log using createLog method for serialized access to the IO functionality. So earlier we saw logging with the multiple thread, in which we did not use log explicitly while logging using same logger object for multiple thread, because it uses handler object which are subclass of this handler class, such as StreamHandler and FileHandler, which by default serialize the access to the IO functionality. While logging with multiple threads, you don't explicitly need to create log on the resources of a handler. And handler class serves as a base class for other handler classes, and objects of this class are not directly instantiated. So we will visit the methods of handler class, because all of these methods of handler class are by default inherited by the subclass of it. So first is create log, which creates the thread log which serializes the access to the IO functionality. Second one is acquire, to acquire the thread log created with the create log. Next is release the thread log acquired using the acquire method. Next is setLevel, which sets the threshold level for the handler, and when handler is created, by default it set level to not set, which means it will log all the messages. Next is set formatter. It sets the given format to the handler. Next is add filter, which adds the specified filter to the handler. Remove filter will remove the specified filter from the handler. So you can have multiple filters set inside the handler object, and with given filter you can remove it. Next is filter record. Applies the handler's filter to the record and return true if the record is to be processed. Otherwise it will return false. Next is flush. It ensures that all logging output has been flushed. Next is close, removes the handler from the internal list of handler and release the resources acquired by it. And handler is closed when shutdown method on the logger is called. Format record. Formats the record. If the formatter is set, it is used. Otherwise the default formatter is used. Next is emit. It takes record, actually logs the specified logging record, and it is intended to be implemented by the subclasses of it, and by default it raises not implemented error. So this emit method is the method which actually outputs the log record, which is a formatted log record. As it serves as a base class, this method is not implemented and it is left unimplemented, so that the classes which are inheriting it or extending it implement it as per the requirement. Next is handle error. It is called from the handler when exception is encountered during the emit call, and it can be ignored silently as shown here by setting the raise exception attribute to the false. So it is generally set in production because when we are dealing with the logging, we are interested in application log, not the logs which are generated by logging module itself. So it is generally set it to the false. Next is subclasses of a base handler class. So these are the subclasses, some of which we have already seen. So we saw StreamHandler, which sends the message to the stream or a file-like object. We will see what are the file-like object in IO module. Second one is a FileHandler, which sends the message to the disk file. So both of these are used by the basicconfig method, which configures the basic logging. So we saw how to redirect the logging message to the file and how to show logging message to the standard error or a standard output. And we will see some of them with the example. So let's begin with the first subclass. So this is the StreamHandler, and it is having constructor with the single argument. It is an optional argument which takes argument as a file-like object stream, and by default it's set to the none. It returns the new instance of StreamHandler class with the given stream, and if that stream is not given, it uses standard error as a by default. So if you give sys.stdout, your output will be redirected to the standard output. So it has method emit, which emit the record to the given stream. If exception information is present in the log record, it is formatted using traceback.printException method. And second method is flush, which flushes the stream. Next is setStream, which sets the given stream to the handler stream after creating the StreamHandler object. and old stream is flushed before setting the new stream. So after creating an object, you want to change the stream, you can use setStream method of a StreamHandler class. It has one attribute which is a terminator, which sets to the by default by /n, which is used as a line terminal when writing the formatted string to the stream. So let's see the example of a StreamHandler. So here we have created the logger object, root logger, set its level to info, and here we are creating StreamHandler and setting the stream to the standard output, and using addHandler method of a logger object, we are adding this handler to the logger object, and after setting it, we are logging the message. And here we are again reassigning the stream to the standard error, and again we are logging the same message. So if you execute it, as we can see, when stream is set to the standard output, it is redirecting log message to the standard output, and when it is set to the standard error is showing the log messages. Next is FileHandler, which writes the logging output to the disk file. So this is the constructor of FileHandler. Take 4 arguments, out of which file name is a mandatory argument. It is given as a file name path plus the name of file, which is opened and used as a stream for logging. Next argument is a mode, which is by default set to the append mode, but it can be given value as per the requirement. Next is encoding. Encoding of a file, by default it is set to the default encoding used by the system. Delay. By default, it is set to the false. Open the file when creating the FileHandler instance. If it is set to the true, it delays the file opening until the first emit method is called. So first log is called until the first log message. It does not open the file if the delay is set to the true. It has 2 methods. First is emit, which outputs the given record, and second is a close, which closes the file. Let's see the example. So here same, we have created the root logger object, set its logging level to info. Here we are creating FileHandler, here giving the name of the file. So here we are not specifying the path, so it will create the logging file in a same directory as this current Python or module is. We are opening in append mode. We are adding this and add handler to the logger object, and after adding it, we are executing the logging method. New file is created and it contains the log message. Next is RotatingFileHandler. It rotates the log file based on given maximum size and maintains the given number of backup file of given max size. So it will automatically rotate based on given backup count and max bytes argument. The constructor takes this argument. First is a file name, is a name of file plus path, which is to be opened for the logging. The file mode, same as the FileHandler. Max byte, when writing to the file, if the file size exceeds the max bytes given argument, it will close that file and create a new file silently for the output, and old file will be renamed using .123 as a backup. Next argument is a backup count. So when file is filled, it is backed up using appending this name .123, and this is the how many number of filled file should be kept. So if the backup count is given 3, it will only keep the 3 file. So when it is having 3 filled file, the new file is created, the oldest one is removed automatically. Next is encoding, same as the FileHandler. Delay, it is also same as the FileHandler. So it has new method do rollover, which does the rollover, and emit method is the same, it outputs the given record to the file. So we'll see the example. Here we are importing RotatingHandler from the module logging.handler. So here we are created root logger with level set to debug, and here we are giving file path from the current directory, which is app logging here in this project, and we are giving path to this directory. So in this directory, it will create log file, and the log file name will be applog. It can contain 500 byte maximum, and backup count is 5. And here we are iterating 500 times and generating a 16 byte hex token 500 times. So it will fill up the multiple logs. So let's execute it and generate the multiple backup file. So after executing it, if we open the file if directory, we can see the 5 backup files are created and it has rolled over automatically because we have set the file size smaller. And if we open it, we can see it contains log records. Next is time rotating file handler. So it will rotate the file based on the time given inside the constructor. A rotated files are saved with the extension of a format of this. Date and time format is appended to the file name. And file name is the same as a file name plus path, same as given for the file handler or the rotating file handler. So for the when argument of a time rotating file handler constructor, it takes one of the value defined in this table. It can assign capital S for the seconds. Generally these two arguments when and interval are given in combination. So when specify one of the argument which specify the period of time, and interval is a numeric value in combination with the when. So here if we specify S second and interval as a 1, so it will create a backup file at each second. So if we specified M, it will create logging file for each minute, for each hour, and for each day. You can also assign it to rotate on certain weekday. So you can assign each weekday beginning from 0, W0 for Monday, and so on. And if it is given as a midnight, rollover occurs at the midnight if at time not specified. If at time is specified with this, then at time is used. Next is a interval specified in combination with the when. Next is a backup count, which is same as we saw for the rotating file handler. It is the maximum amount of a field log file which needs to be preserved, and oldest when it counts are greater than the given backup count, the oldest one get removed automatically. Next argument is encoding. So if you have explicit encoding, you can give it, otherwise the system default encoding is used. Delay is same as for file handler. It will open the file when the handler object is created if it is given as a false. If it is given as a true, it will only open the log file when the logging output is emitted. Next is UTC. If set to UTC, UTC time is used, otherwise it uses the local system time. By default it is set to the false, so it will take the local time. At time, it is by default set to the none, but if it is given, must be an instance of datetime.time which specify the time of the day when the rollover of a file occur. So either you can give at time or you can specify when and interval, and both are specified, then what happens is mentioned in this third column. So at time contains the time of the day when the rollover should be performed. Let's see with the example. Here we have created an object of time rotating file handler which will create a new log file at interval of 2 seconds, and it will only keep the 3 backup file, and we have added to the logger object. And here we have used time.sleep in order to simulate time required to process or create the new token. So let's execute it. So it's finished its execution, and if we open the folder, as we can see, multiple backup file filled with the log record at the interval of 2 seconds apart. So here we can see each backup log record file at the interval of 2 seconds. Now here one thing to keep in mind, it will only create backup file at given interval if at least one emit or the logging is done in every that duration. So for this example, it will only create a new time rotating log file if at least one log is created in 2 seconds. We have created time logging for 2 seconds interval. So in order to create a new log file every 2 seconds, there must be one log message executed at least in 2 seconds interval. Otherwise it will not follow the pattern of creating a new log file at that particular time interval. Next is SMTP handler. It sends the logging message to the email address via SMTP. So this is the constructor. It takes mail host for the SMTP port. A start string representing the host name is used, or else you can give a tuple object of host name and port. ToAddress is a list of string which contains email address to whom the email of the log message to be sent. Credential, it takes tuple object of name and password for the authentication. And secure, if the credential argument provided the secure argument specified to use of a secure protocol such as TLS in tuple key or tuple key file and certificate file. Next is timeout, is a communication timeout with the SMTP server, and these are methods of it. First one is emit, it formats the log record and sent it to the specified email address. Next is a get subject, takes record and defines subject for the record. It can be overridden to return a custom subject based on condition. Next handler is NullHandler, which discards the log records which are sent to it. Then constructor does not takes any argument and it returns the NullHandler instance which perform no operation. And these are the method. Emit, it does not do anything. Handle doesn't do anything. Create log returns none for the log because no underlying IO to which access need to be serialized. So basically it does nothing. When we are discarding the log record, this NullHandler is useful. We will see its example in combination with the next handler, MemoryHandler, which buffers the logging record in the memory, which can be periodically transferred to the target handler. So it is used for buffering log records inside the memory. So this is the constructor for the MemoryHandler. First argument is a capacity, which defines the maximum number of logging record to be buffered. It defines capacity in terms of records, not in terms of bytes. Second argument is a flush level. By default it is set to the error. It flushes the buffer when the level which is defined at the flush level of log record is raised. So whenever logger.error method is used for logging the error message, it will flush the content of buffer. Target is a target handler to handle the log record when the flush is executed. So if it is not given any flush level, so by default when the error occurs, it will transfer all the log records which are stored inside the buffer to the target handler given here. And it is a required attribute, target. If it is not specified in the constructor, must be set with the set target. Next is flush on close. By default it is set to true, flushes the buffer log record to the target handler when it is closed. And these are the methods. First one is a should flush, returns true if the buffer is holding the maximum number of records. Next is flush, which sends the buffer record to the target and clears the buffer if target exists. Next is set target, which sets the current given handler target to the memory handler object. Close, which call the flush method, which sends the buffered log record to the target handler and set the target to the none and clears the buffer. Basically it frees up the resources. So let's see the example. Here we are creating logger object of root, and here we have created FileHandler, which will be the target handler for the memory handler, and we have created NullHandler object to discard the log records. And here third one is the memory handler, which has capacity of 15 log records, and by default it will discard all of the record which is stored in the memory, and flush on close is set to the false. And we have added the memory handler to the logger object. So if we iterate over multiple iteration of generating hex token of 16 bytes, as it is set its target handler to the null, it will store 15 log record inside the memory buffer, and when it is full memory buffer, it will transfer all this record to the target handler, which is NullHandler, and it will discard those log records. But we know that by default for the memory handler, flush level is stored to the error. So we are directly discarding the output when the buffer is full. But when the exception is raised, we are changing the target to the FileHandler, and we are logging the message with the error method, which will flush the buffer to the target handler. In this case it is FileHandler, and after finishing the flush, we know it will definitely flush the output because the target or the flush level is set to the error, and we are logging the error message, and after flushing we are setting the target again to the NullHandler. So if we execute it and see the output, we can see here it only contains 6 record, but we have loop over 5000 iteration of generating hex token and logging it. All of that are discarded because we have set the capacity of a 15 records only. So after logging any number of debug message or any message which is below to the flush level defined here error, it will automatically discard because the target is set to the null handler, and when it is exception is raised, we have set the target to the file handler and we are logging with the error message which is same as the flush level error, which will flush the buffer to the target handler. In this case is a file handler. So then only it is redirecting all the log record which are stored in the buffer currently to the target handler, which is a file handler, which will log the given log record to the file. Next is watched file handler. It watches for the log file changes. If the file is moved or removed, it closes and reopens the file. It watches the file it is logging to and intended for use of Unix or Linux system only. If the file changes, it is closed and reopened using the file name. And file change happens when the Unix programs such as new syslog and logrotate performs the log rotation. So you have a Unix or Linux log system configured, and on top of it you are running Python application and you want to use logging with the file handler. You can use this watched file handler, which will work with their Unix program. Take similar arguments, file name, mode, encoding and delay, which is same as a file handler. It has a unique method reopen if needed, which checks to see if the file has changed and if existing stream is flushed and closed. If it is changed the file, then existing stream is flushed and closed and reopens the file again. Next is QueueHandler. It's a multi-threaded handler in which handler works on a separate thread from the thread which performs the logging. So here for the file handler or the SMTP handler, the receiving logging message and performing the logging was done by the single thread. So for the SMTP handler, it may slow down its performance because sending mails requires some time. So with using QueueHandler, we can detach it. So when logging a message, you can create a queue and you can enqueue the logging request, which will be handled by a different thread which actually performs the logging of the message. It will reduce response time of a application also. This is the constructor of a QueueHandler class, which returns the new instance of a QueueHandler class with the instance initialized with queue to send message to. It takes one argument queue, which can be any queue-like object, but we can use simple queue instance. These are the method emit, which enqueues the result of preparing log record. If the queue is full, handle error method is called. Here we can see the whole process is detached. It just enqueue the result of preparing log record. It does not perform actual log record. So if you see earlier handlers, it does perform logging too. It only calls the prepare. Prepare method prepares the log for the queuing. Object written by this method is enqueued. It formats the message argument and exception information if present, and it removes unpickable item from the record. And this method can be overridden for converting the record to a dictionary or a JSON string, or send a modified copy of a record while leaving the original copy intact. Next method is enqueue. Enqueue the record on a queue using put no wait method and can be customized as per the requirement. So it will invoke queue's put no wait method to enqueue the given record. So this handler will only add log record to the queue. Now the separate thread of a QueueListner class is created, which will handle the log record from that queue. It returns a new instance of a QueueListner class initialized with the queue to send message to and list of handler which handle the entries placed on the queue. So if we see the constructor of it takes queue, same queue object which is passed to the queue handler is passed here. So it will receive the request from this queue and it will pass their log record to the list of handlers specified in the constructor. And it has one optional argument, the respect handler level false. If passed as a true, it matches the handler level with the message level before passing message to the handler. And by default it is set to false, will pass every message to each handler. Handlers, it handles the queue entries. So these are the methods of QueueListner. It will perform dequeue operation, dequeue a record and return it optionally block argument. And block, it determines the get call on queue is blocking or non-blocking. It uses get method of a queue which by default blocking, which can be override to customize behavior. So dequeue method is by default blocking. Next is prepare record. Prepares a record for handling. By default it returns the record passed to it as it is, but you can override this method for the customized behavior. Handle record, it handles the record. It loops through all the list of handlers given at the constructor and passes the same record to return from the prepare method. Start, it starts the listener in the background thread to monitor queue for the log record to process. And stop, stops the listener. Task the thread to stop and wait for the thread to stop. If this method is not called before your application is exit, there may be some record left on a queue which will remain unprocessed. Enqueue sentinel, writes the sentinel to queue to tell listener to quit. It uses put no wait by default. So let's see it with example. So here we have created a simple queue object, pass it to the queue handler, and here we have created a StreamHandler which will be used as inside the QueueListner class. So here we have created QueueListner object and same simple queue is passed here, which is given as inside the QueueHandler class, and by default StreamHandler will be handling our enqueued log message. So we have added the QueueHandler to the handler of logger object, and in background we started listening to the QueueListner object. So any logging message will be handled by the handler which will enqueue the log record to the log, and in background it is checking the log queue constantly. So when it will encounter any log record inside the queue, it will dequeue the log message and process it. And here we have specified the StreamHandler. The QueueListner object will redirect the log records output to the sys.standard output. And here you can also use SMTP handler instead of StreamHandler if your application is mailing a log record which is logged at a particular log level. And after finishing it, we are executing listener.stop to stop the background thread. So if we run it, we can see the log message on the system.standard output. Next is third logging component, filter. Filter can be used by handler or logger for more specific filtering from filtering record based on log level. So earlier we saw logger object which has level attribute, and whatever the level set for the level attribute, depending on that your log record gets filtered. But if you want more specific filtering, then you can use filter class. By default, base filter class filters the log messages based on logger hierarchy. So this is the constructor of filter class, which takes one parameter name which takes string argument, and based on given string which represent the logger hierarchy, your log records get filtered. So based on given logger hierarchy, the events which are below the given logger hierarchy are get logged, and all the other events which are not children of the given logger hierarchy as name are ignored. For example, if you have given the name parameter of a filter constructor as a.b, then it will allows the event to be logged by a.b.x or a.b.x.y or a.b.z, but it will not allow a log record to pass through logger hierarchy of a.p or b.q because they are not below the given logger hierarchy. And if it is not initialized with any string, by default it is empty string which will allows all event to be passed. so it will not filter any of the log record. And filters are attached to handler before any event is emitted by the handler, and filters are attached to logger. Any event is logged using logging methods such as info, debug, etc. It has one method, filter, which takes one parameter as a log record, and based on the attribute value of log record you can decide whether to process that log record or discard it. So for discarding you can return 0, and if you want to process log record you return non-zero value from this filter method. So first we will see the base filter class, its default implementation, and then we will customize it. So here first we will see the logging hierarchy or the module hierarchy, which is imported here. This file logging with filter is inside app logging filter here, and it is importing 3 modules. So first module is inside app logging package A1 and module A2, which is having one method which prints the message from its package and module name. So all of 3 modules have similar function which prints its package and module name. So same as package B inside app logging and module B2 inside it, which prints the message of its module name. And third import is outside of app logging, here package B, and inside it we have module M1. So we are importing 3 modules from the different packages, and now here we are creating root logger and set setlevel to the info, and here we are created StreamHandler which will redirect your log records to standard output. Its level is set to info. Now here we have created the base filter class object, and here we have given the name or the logger hierarchy as a app logging, so it will allow the children of this logger hierarchy. So if we see this import module, we can see here module A2 and B2 are from the children of app logging, but module M1 is not belonging to the logging hierarchy app logging. So if we attach this filter to the handler, and that handler is attached to the root logger, and after that if we start logging all of 3 modules, here we are invoking that logging method, the logging event generated by module M1 will not be processed because it is not belonging to the same logging hierarchy given as a constructor argument. So let's execute it and see the result. So as we can see here, only we are able to see messages from module A2 and B2, but this log message is discarded because it is filtered by the base filter object. Now we can also customize the filtering logic by inheriting the base filter class. So we will create subclass of a filter class and override the filter method with our custom business logic to customize the filtering. And filtering can also be used for counting how many records were processed by particular logger or handler, and adding, changing or removing attribute from the log record being processed. Before processing a log record, it is passed to the filter, so you can add or remove any attribute you want from the log record object. So this is the syntax of a filter method. So this is filter method which takes only one parameter of type log record, and it returns the integer value. So first we will refresh the attributes of log record object, because these are the information of logging event which are available to the filter method, and based on this information we can process or we can make decision to whether to process this log event or to discard it. So this is the same as we saw earlier. This is the arguments which are passed to the logging method. Is a timestamp, exec info is exception information, exec test is a cached formatted exception, file name, the name of file, function name, the function from which the logging message or logging event is raised, level name, logging level name, numeric log level name, line number at which the logging event is invoked, the module name, the millisecond part of a timestamp when the log record is created, message string which is passed to the logging method, the name of logger instance, the full path name to the source file, process ID, process name, relative created time, millisecond in time from when the logging event is raised relative to the when the logging module was loaded. Stack information is a stack information for the call, thread ID and thread name. So these are the all information which are available inside the LogRecord object, and we can access it inside the filter method. So let's filter based on some of the attribute inside the LogRecord. So here we have created a subclass of a filter class. So this is a base filter class and this is our custom filter class, of which we will create the filter attribute. So here we are overriding the filter method, which takes one LogRecord attribute and returns the integer value. So first we will print, for the demonstration purpose only, what are the attributes of LogRecord which we are getting here from the event is raised, and we are filtering the LogRecord based on its message. So if the LogRecord message contains failure word inside it, then we are processing it, otherwise we are discarding that event. But while processing it, we are also printing each attribute of a LogRecord which is passed to this filter method. Now here we are getting the logger, and we have set the LoggerLevelHandler, and here we are creating the object of a filter class. So filter class is created and filter is added to the StreamHandler. So here it is not initialized with any stream, so it will redirect the LogRecord output to the standard error, and this filter is attached to this StreamHandler, and here we have attached the formatter also to the StreamHandler and attaching this StreamHandler to the logger. Now we are invoking a function which logs the message which contains the failure word. So this message must be passed through this custom filter and it should be visible on a standard error. But if we raise another log event which does not contain failure keyword, this should not be passed to the standard error through the StreamHandler. So let's execute it and see the output. So this is the output of a standard error. So here we can see we have printed the connection failure log event with the information here. So all its information is printed to the standard error with stack trace, and we have also raised warning message for zero division error, which is not printed on the standard error because it is filtered by the custom filter class. And if we see the stdout output, we can see what are the log records received by the custom filters filter method. So this is the first log record received for the connection failure. So here we can see custom attribute pod, the argument which is passed to the logging method. This is the code which we have passed to the logging method. It's a created time, unique timestamp when the log record was created. Exception information, because here we are not providing any exception information, so it is none. This is the file name, name of the file, function name from which the logging message is executed, level, logging level, line number, module name. This is the message we pass to the logging method here. This is the full path name of a module file, process ID, process name, relative created time, stack information, because we have set the stack info is equal to true, thread ID and thread name. So as we can see, all the attributes and its value of a log record object. So based on this information, you can make decision whether to log the particular log record or to discard it. So same as the second log record is also received by our custom filter objects filter method. So as we can see, these are the parameter it gets. So it is raised from an exception. So we have passed the exception information. So it contains here the exception information, zero division error, and its traceback object and all the other information also. But this log record is discarded because its message does not contain the failure word. So this way you can create your custom filter by overriding the filter method. Now creating subclass of a base filter class is not required. Any function or callable which takes only one argument as a log record and returns an integer, can be replaced on the filter object's filter method, and that will do the same thing as we saw. So what do we mean by that? So here, instead of creating subclass of a base filter class, we are only defining a custom filter method which has same arguments, which only takes one parameter of log records and return the integer value. So same business logic, but we are not creating a new subclass. Instead of that, when we are creating an object of base filter class, we are replacing the filter attribute or filter method of that base filter class with our custom filter method. And if we execute it with the same set of logging message, it will produce the same result. So as we can see, it is getting 2 records and it is only processing the record with the failure keyword. So this can also be done without creating subclass of a base filter class. The next topic is LoggerAdapter. It adds the contextual information to log message. To add contextual information, object of LoggerAdapter class can be wrapped around the logger instance, and it has the same logging method which are available to the logger object such as debug, info, etc. It just delegates LoggerAdapter methods to that logger object's method after invoking the process method of LoggerAdapter class. So how does call work? So this is the syntax of it. For example, the LoggerAdapter class has same set of logging methods such as debug, info, warning, error, etc. And each method is having this kind of implementation. First, what it does, it invokes the process method of the LoggerAdapter class with the same message and keyword argument, and whatever the message and keyword argument written by the process is delegated to the logger object's its own logging method debug, and it is executing the same function which we are executing on the logger object. But what we are doing extra is we are invoking the process method of the LoggerAdapter class, and in this process method we can write our custom business logic to include some contextual information which is passed when processing the logging event. So by default, implementation of a process method of LoggerAdapter class returns the given argument as it is, so it does not have any effect on logging method by default, but you can customize it by overriding the process method. So if you create a LoggerAdapter class and if you don't override the process method, it will have same effect as if you are running a logging method on a logger object instead of LoggerAdapter object. And inside the process method, the key value pair of a dictionary object passed using extra parameter of logger method are used for formatting custom messages. And while invoking logging method of LoggerAdapter class, it requires you to pass dictionary object with the set of key which is used to format custom message, and their value can vary. So let's see it with the example. So here we will create a subclass of the LoggerAdapter class in which we know that it has all the logging method which calls the process method before logging method of the logger object is called. So this will be wrapped around the logger instance. So before calling any logging method, it will call the process method, and whatever the business logic written inside will be attached to the message and keyword argument which will be passed to that logging method. So here what we are doing is we are attaching some contextual information to the original message string passed to the logging method. So here we are inserting client ID extracted from the extra parameter. So we know extra parameter from the logger methods such as debug, info, warning, etc. It is passed as a dictionary object, and from that dictionary object we are accessing the client ID key. So this message will be attached automatically prepended to the message, and we are passing the keyword argument as it is. Now how we will use it? So first, here we have created the logger sets its logging level. We have created StreamHandler and set its logging level and attached the custom formatter to the StreamHandler. And here we have added the handler to the logger object. And here we are first creating a dictionary object which is passed as an extra information to the LoggerAdapter. So while creating an object of our custom LoggerAdapter class, we will pass our existing logger object plus a dictionary which is containing the key value which are used to add the contextual information to the message. So based on that, LoggerAdapter object is created. Now we can use the same dictionary object to log multiple messages and their value can be changed. So this is the initial value, and depending on the program we can modify as per the requirement. Now we know the logger object is wrapped around the LoggerAdapter class. So we will invoke the same logging method which we are invoking on the logger object. So LoggerAdapter.debug, if we execute it with a simple message, it will append this contextual information to the message given here before processing the LogRec. And we have already passed this information here, so that information will be replaced here. And here we are using again logger object. So you can also use logger object to log the default messages in which you don't want to add any contextual information. So this will be passed as a normal message. It will be processed as a normal logger message. Now here we are changing the value of a dictionary which is passed as a constructor of a custom LoggerAdapter class. After that, if we again log record using LoggerAdapter class, it will attach this new information or the newly modified value to this message. So let's execute and see the output. So as we can see here, we got 3 messages on using StreamHandler, which is redirecting output to the standard error. So first message is attaching this contextual information, login is attempted. This is a normal message which does not contains any contextual information because we are invoking a logging method on the logger object which is not wrapped around this LoggerAdapter class. And here we are modifying this dictionary value, and after modifying it we are again using LoggerAdapter class to log event. Then it is including contextual information which is currently modified or latest contextual information inside the LogRecord. So this way we can attach the contextual information to logging event without passing the same dictionary object each time. So earlier we saw if you modify any of this format here in formatter, then you need to pass each time the extra parameter. Instead of that, you can create LoggerAdapter class and use that LoggerAdapter object which is wrapped around the same logger object to log that extra information without using that message each time. So instead, if you are not using this, then you have to manually add this client information each time in the message, or you can modify this, then you have to attach the extra information at each logging method. So the best solution is to use LoggerAdapter. So based on the given value, you can log the custom log messages with the contextual information. Next is fourth logging component, formatter, which returns the formatted string by replacing the LogRecord object's attribute value with the key specified in a log format. So we know log format contains the keys or the formatted keys which gets replaced from the values in the LogRecord object. So after replacing or after formatting the format message, it returns the final formatted string which we are seeing on a file or a StreamHandler depending on the handler attached to the logger object. If we want to customize the final output, how it should display the formatted output, then we can use the formatter class to modify how the output of the logging should be visible. So format class, when application requires special formatting, custom formatter object of a format class is created. So this is the constructor of a formatter class which take 3 optional argument. First is fmt. By default it is set to none, so raw format as it is used, and you can assign here the formatting parameters as we have described earlier in the basic config. So same formatting symbols or the attribute you can use to construct the log format, and based on defined attribute in the log format, those attribute will be replaced with the value from the log record when processing the log. Next parameter is dateFMT. It's a date format. If it is not given by default, it uses this. So you can use any date format as we have discussed in a date time module. So you can use any of the date format given here, so you can customize it. And last one is the style. So by default it uses %style string formatting, but it can also be given value from $ or the curly braces as we saw for the string formatting, and this is from the string templating. So percentage here dictionary key and the type of value. For $, it's the key name, and for curly braces you can also define the dictionary key inside it, which will be replaced with the log records attribute value. Now formatter objects has following methods. First is a format. It takes one parameter as a log record, which returns the log message in string by replacing the log record information specified format. Format time. So format time is called from the format method, which returns the formatted time depending on the given dateFMT in the constructor. Format exception. So it formats the exception which is called from the format method, which returns by default it uses traceback.printException to format the given exception. And last one is print stack. It takes stack info, and it is also called from the format method to format the stack trace if we need to print the stack trace. By default it uses traceback.printStack to format the stack trace. Now if you create a subclass of formatter class, in order to customize the formatting, you can override any of this method in order to get customized behavior. So if you want to change the format of exception, stack trace or date time, you can override it. And it has one attribute which is converter. By default it logs the local time, but you can give time.gmt time if you want to log the GMT time by default. So let's see an example of formatter. So here we have created a root logger, sets its level to the debug, and then we have created StreamHandler, which will redirect your logging output to the standard output. Here we have created a formatter with the formatting message of style curly braces. So inside curly braces we are defining the attribute name, which is a key, and we are setting that formatter to the StreamHandler, and StreamHandler is added to the root logger object. Here we are again getting another logger object of myAppLogger logging hierarchy, and we are logging the log record of debug level on that. And here we are creating a second formatter. So first was with the style curly braces, now it is with the $, and we are replacing the handlers formatter with the newer formatter. So the newer formatter which we are created here will be used, and here we are modifying the converter attribute to time.gmt time, so it will log the GMT time instead of the local time. And we are here again logging the message. So if we execute it, so as we can see in the first, if we see the time, it is printing the local time for the first message for the first formatter with the curly braces style formatting, and for the later part it is printing the GMT time using formatting the $ style. So this way you can use or customize the formatting of a formatter class. Next is configuring logging in your application. So it can be configured in 3 ways. First, using Python code. So creating logger, handler, formatter objects in your Python code and setting the handler and formatter to the logger object. So for example, this is how typically we have configured throughout the examples. So first we have created logger, then handler, formatter. So setting formatter to the handler and adding the handler to the logger object. So this way we are creating the logging configuration. Second, you can use logging.config file to read the configuration of logging using FileConfig. So you are detaching the configuration from your Python code. So here in app logging folder, we have logging.config. So in this logging.config file, we will define the logging configuration and we will read it using FileConfig method. Here first we will define the logging components such as logger, handler, formatter, and for each logging component we will define keys. Keys will be the name of their component. In application we are using two logger object. First is a root logger and second is a module one. And we have one handler. The name of handler is a console handler. Formatter is a simple formatter name. And now we will define each component's attribute and customization based on the given keys. So first we will have a logger root. So we will set its attribute level to the debug, and we are attaching console handler to the root logger. Then we are defining module one logger. Here set its level to debug, handler to console handler, qualified name is a module one, and we have set propagate to 0, which will not propagate its logging event to the parent of it. Now next is handler. So we have defining console handler is a class of StreamHandler. Its level is debug. Formatter, it uses simple formatter and it has argument to the constructor of this StreamHandler is sys.stdout, which means it will redirect your logging output to the standard output. And last component is formatter is a simple formatter which uses this format to process the log record, and its qualified name is module 1. So it is defined in this module. So we have this configuration file, and now we will import the configuration using FileConfig method. So FileConfig method is inside logging.config, and after importing that configuration we can start getting the logger object and we can start the logging. So all the configuration made inside the logging.conf will be imported. We don't need to create objects of the logging components. It will be automatically done. So if here only code is we are getting the logger module 1. So module 1 logger will have this console handler of StreamHandler, which is attached with a simple formatter. So if we execute it, it should print message with the same format defined in a simple formatter, and it is redirecting output to the sys.standardoutput as we have configured in the console handler. So this is the second way how you can configure logging in your application. Now third way is a recommended way of configuring logging in your application using a dictionary. So we will create a YAML file or a JSON file, and we will read the configuration defined using YAML or JSON file format into our application using dictionary config. And this same dictionary config function can also be used to parse configuration defined in a Python dictionary. So first we will see the YAML file. So here we are defining the logging components. So this is the mandatory for the dictionary config. So version 1 is a default and it has only version 1. So it should be kept as it is. After that we will define the logging component. So first we have defined formatters. So we are using only one formatter. Its name is simple and it using this format. Handlers, we have one handler. Its name is console and it is type of StreamHandler. Its level is debug and it uses formatter of simple. And for stream, in order to define external object, this syntax is used. So it will give a stream as a standard output, which will redirect your logging output to the standard output. And here we are configuring logger. So it is only one logger. Its name is module 1. Its level is debug. Its handlers are console handler only, and it has set propagate to no, so it will not propagate to its parent. And here is a by default root logger and its level and its handler. Now we will import this file inside our Python file. So first we need to import dictionary config from logging.config, and in order to read YAML file you need this YAML module. So first you need to install it using pip install pyyaml, and if you are using PyCharm you can go to settings, interpreter settings, click here to add, and you can search here and click on this and install package. I have already installed it. You can install it. So it will remove your import error, and afterwards here we are importing this logging.yaml. First we will check that whether the file is exist. If it is existing there, then we will open it in a read mode and we will load the config, and after the config is loaded we will pass that object to the dictionary config, and dictionary config will create all the logging component which is configured inside the logging.yaml. And after that we are retrieving module 1, which will redirect your output to the StreamHandler sys.standard_output of this all logging message. So it has set level to the debug, so it will contain all of this message in the given formatter in this format. So let's execute it. As we can see, it is using the logging module 1, and this is a logger object of module 1 hierarchy of this message levels with given format. So same way you can also create a JSON file. So here we have created a JSON file same as we have created for the YAML file. It is the same way, the syntax is as per the JSON. So we are creating the same kind of configuration using JSON file. So here we can see the dictionary config using JSON file. So first we are checking whether the file exists on given path, then we will open it and extract the config from it, and using dictionary config we will read the logging configuration. So it will create the logging object. Now we will execute the same logging message we saw for the YAML, and if we execute it will produce the same result because we have used the same configuration in both of the file. So this is the way you can configure your logging in your application. The recommended way is to use dictionary config, and you can configure your logging inside JSON or YAML file and you read it in a detached manner. So that brings us to end of the video.